welcome to our chemistry online class. As far we discussed about so many things, and we know we have drawn Lewis structure and all. So if we check the Lewis structure, how these compounds got that structure? How can we understand a structure of molecule? For example, if we draw water molecule, why we are drawing water molecule like that? So in order to draw a structure of a compound, there we have to understand some basic factors. So there is a theory behind this. This theory is known as VSEPR theory. So what do we mean by this VSEPR theory? This theory is the expansion of the theory is valential electron pair repulsion theory. It was suggested by Sidgwick and Powell in 1940 and it was developed. So if you want to draw the structure, the exact structure, we know there are some limitations in the Lewis structure. So if you want to draw the exact structure of a molecule, we have to consider the total number of bonding and non-bonding electron pairs in its valence shell. We know in order to make a chemical bond or in order to make any bond, the valence shell electrons are take part in any reaction. For example, if making the covalent bond or ionic bond, the valence shell electrons either transfer or sharing. So it is occurring in the valence shell. So the valence shell electrons are take part. So the total number of bonding and non-bonding electron we have to consider in order to draw the structure. So we'll see it in detailing. So this theory, the theory is known as valence shell electron pair repulsion theory. So there are several postulates of this theory. If you want to make a theory, there are some postulates. So the first postulate is the shape of the molecule is determined by the repulsion between all the electrons present in the valence shell. It means that if we take a molecule, in the valence shell of the electron, we know all electrons having the negative charge. So we know the negative will repel each other. So how much the repulsion is present in the valence shell, the shape of the molecule is determined by the repulsion between the electrons. This is the first fact. Then second, electron pairs in the valence shell of the central atom repel each other and align themselves to minimize this repulsion. For example, in your class, if people are sitting in a bench, if you two people are fighting each other, what will do? Teacher make one student to sit in other place. Similarly, so there is the changing of the position. So in order to decrease the repulsion between the valence electrons, atom will align or the electron will align themselves to in order to decrease the repulsion. So they will move apart to minimize the repulsion. And lone pairs electron takes up more space around the central atom than bond pair. So lone pairs electron will take more space. Lone pair attracted to one nucleus but bond pairs is shared by two nuclei. So the minimum repulsion to the state minimum energy and maximum stability of the molecule. If a compound having minimum repulsion, then the compound is more stable. So here we can see the repulsion strength. So the lone pair repulsion is more compared to lone pair bond pair and bond pair repulsion. So lone pair and lone pair electrons having high repulsion. For example, if we are taking NH3 molecule, in NH3 nitrogen having two lone pairs of electrons. So there will be more repulsion in the compound. So in order to decrease the repulsion, the how much far apart these electrons can move, like the way it will rearrange. The lone pair repulsion will be more compared to lone pair bond pair and bond pair repulsion. And repulsion strength, triple bond having high repulsion, double bond having lesser than triple bond and single bond. So if there is lone pairs, the slight distortion of the bond angles from the ideal shape that you can see further, you can see that is if there are lone pairs of electrons, if we are thinking if there are two electrons, so this will be the shape. For example, linear shape will be the example. But if there is a presence of lone pair, the molecule will change the bond angle. I hope you know bond angle. So the magnitude of repulsion between bonding pairs of electron depends upon the electronegativity difference between the central atom and the other atoms. So there are some factors affecting our VSEPR theory. So how can we predict the geometry? Geometry means the arrangement. Geometry means the shape. How can we understand? How can we draw? How can we determine the shape of a molecule? So that there are several steps. The very first step is determine the central atom. We have to know which will be the central atom. Then draw the electron dot structure. We know how to draw the electron dot structure that we have discussed earlier. And find the arrangement of electron pairs, find arrangement of bonding pairs, determine the geometry based on the bonding pairs. So here the role given to bonding pairs of electron. So let's see by an example. So if we take a molecule, the shape will contain only bonded pairs of electrons. So if we take for example beryllium hydride BH2. So as we know BH2, we have to consider, the first step is we have to consider the central atom. So as we discussed earlier, which number is less? For example, if beryllium hydride, we know there are one beryllium and two hydrogen. So beryllium is a fewer number, so it will be the central atom. So if we draw beryllium hydride, we know in beryllium what is the atomic number of beryllium, it is 4. So electron configuration is 1s2 2s2. So in the valence shell of beryllium having 2 electrons, but as a molecule we know beryllium having covalent bond. So there is one, here you can see 1 electron of beryllium is there, 1 electron of hydrogen is there. So 1 electron of beryllium will be here, 1 electron of hydrogen will be there. It is denoting the bond. So if we take the beryllium in beryllium hydride, that is BH2, there are 2 electron pairs. There are totally 4 electrons are surrounded. 4 electrons are surrounded by beryllium. Here 1, 2, 3, 4. So 4 electrons pairs are there. So this bonded pair electron will repel each other. So these all are electrons. So it will repel. So in order to decrease the repulsion, the 4 electrons will arrange in this manner. That is totally 180 degree. The bond angle is 180 degree. Difference is there. So this geometry is known as, this arrangement, this 180 degree angle arrangement is known as linear arrangement, because here you can see linear in the same line. So this arrangement is known as linear. Similarly, if for each angle, for each number of electrons, there are different geometry. I will move to next, that is trigonal planar. That is if bond angle is 120 degree and there are 3 pairs of electron, such compounds are known as compounds having trigonal planar arrangement. So you have to know this all. For example, if you take boron, here you can see this one bond is denoting 2 electrons. So 2, 4, 6. So we have to find BF3. So boron is fewer number. So boron is the central atom. So first step is find out central atom. Second step is find out number of bond pair electrons. Arrange them. So it is 6. So 3 bond pair electrons are there. So the arrangement is trigonal planar. It's like a triangle. So 2-dimensional structure, trigonal planar. So the bond angle is 120 degree. Similarly, for each compound there is certain bond angle, etc. If we take carbon, we know 8 electrons are there. 1, 2, 3, 4. So the geometry is known as tetrahedral. The bond angle is 109.5 degree. For each molecule, it should be equal. If the bond angle is 120 degree between here also 120, here also 120. Similarly, CH4 molecule. And if you take PCl5 and all, the bond angle is, there are two type of bond angle. This is known as trigonal by pyramidal. So bond angle is 120 degree, and here it is 90 degree, here it is 120 degree. If the central atom having 6 electron pairs electrons, that is for example our SF6 octahedral geometry, it will show octahedral geometry and bond angle is 90 degree. If there are as we discussed about only bond pairs of electron, if a molecule is having lone pairs too, so what will be there? So central atom with 4 electron pairs, that is tetrahedral. As we discussed, it is tetrahedral. But if we take nitrogen having 5 electrons in the valence shell. So according to this theory, it should be tetrahedral. If there are 5, then it is tetrahedral. But actually it is trigonal by pyramidal. Why it is happening? Because there is, if we take nitrogen, it contains lone pair of molecule, 2 lone pair of electrons. So in order to, we know the lone pair bond pair repulsion will be more compared to bond pair repulsion. So in order to decrease this lone pair bond pair repulsion, the arrangement, the spatial arrangement will vary, so the slight distortion will be there. So the bond angle will be 107 degree for 8 minutes. Similarly, if there are 4 electron pairs, there are 4 lone pair of electron, again the molecular geometry will be V shape. From linear it will move to V shape, bend shape. So the repulsion between lone pair will be more. Here there are lone pairs. So in order to decrease the lone pair, it have to move from 109 degree 28 degree minutes to 104 degree. So water molecule having the bend shape rather than linear. Similarly, sulfur, our SF4. This is seesaw structure. Then SNF4, SCF4, square planar. It should be square planar, but it is octahedral in geometry because lone pair bond pair repulsion. So there are some distortion cases are there. So if we take like that, we can see. So there are some limitations. It failed to explain about the isoelectronic species. It's not considering the substance size. So it failed to explain the atomic overlap, etc. So then next model came, but this theory is very important to in order to know the structure of the molecule. Thank you.